Here the plain text is help me now. Now what we have made here, we kept P as it is. We moved L to the second row and moved it to one portion to the right. Then we moved the E to the third row, two portion to the right of P. Then A, we moved total 3 positions to the right and represented in the fourth row. After that, S comes, which is the third row to the right position. Then E comes, second row to the right position of S. Then we arrive at H. Like that, we organized the please help me now into rows and columns. After arranging this, we pick all the fonts in row 1 first. We are having P, H and N. We write them first. Then we take the second row where L, E, 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 O is appearing. We write it next. Then we have got E, S, L, M, W. We write it next. Then write down AP. Like this, for plain text, please help me now, we obtain corresponding ciphertext. Now we shall take another example. Here, a message meet me at park. So Alice is interested in communicating this message to Paul in an encrypted form, and after encryption, ciphertext will be obtained. So he has used a technique called rail fence cipher. Means 2 rows will be formed here. To make the row, what he has made is, in the first font, in the meet, then second font has been pushed one level down and shifted to one position. Then E comes. Then fourth letter T will push it down and move towards right. Like that, the meet me at park has been arranged like this. After that, all the fonts in the first row are written first. So we get M, E, M, A, T, E, A, K. Then we write all the fonts starting from left to right in the second row. That is E, T, E, T, H, P, R. Now we shall take another example. We are interested in converting hello world into ciphertext using transposition cipher. So what we have made here, we have written EH. The 9 characters each row, and we create the rows accordingly. So message from Mary Stuart kill the queen. After removing the blank here, what string we get, we write here. In the first 9 characters we write down MESSAGEFR. After that we proceed further, write down in the next row, then remaining the next row, then whatever is left over, that is occupying the fourth row. Like this we represent. After representing each rows, each column we take down MOAE, then EMRQ, then SMTU. Like that we write down, and then finally as a group of 5 fonts we represent the cipher text. Now we shall move towards example 9, which is representation of total matrix. Here we shall take the example plain text, begin operation at noon. Here what we do is we remove the blank spaces and we get the string of letters. When we do it, so we are having 20 characters here. 5 character, blank has been removed. Then we are having 8 characters, 8, 5, 13, 15 total. We are going to have this total 20 characters are there. Now we represent them as 5 rows and 4 columns. The first row is having BEGI, then this N is going to the next one, OPE, then from R next, then the remaining font to the next, and after that the next. Like that we are representing all the fonts here. So now once we represent this 5 by 4 matrix, we are making use of certain additional rules. So in the step 2, we are interested in rearranging the rows by moving row 1 to 3, row 2 5, row 3 to 2, and row 4 to 1, and row 5 to 4. Like that, when we make around the first one, we move it to the 3rd position. Second one, we move to the 5th position. Like that, when we make arrangement, the resulting matrix is going to be ONAT, RATI, BGI, NOON, and NOPE. Once by making this row arrangement is carried out, now the 3rd rule we want to apply. Please understand that these rules only will be ensuring transposition ciphers to happen, and they are unique. It has been defined by sender and receivers. So in this one, these rules have been given, accordingly we are doing. So it has been asked that after making the changes in the row, okay, rearrange the columns by using the rules like that they specify. So column 1 we move to 4, column 2 we move towards 3, column 3 we move towards 1, and column 4 as column 2. So by doing it, we will get this ATNO, TIAR, GIEB, ONON, PEON as the matrix. Now once we do it, then we are picking up first row ATNO, we write down the fonts, then ATIAR, we write down next, GIAB, we write down to the next, like that we proceed. By doing it, we get this particular cipher text. Now we shall move towards the next concept called other cipher properties. Here we are discussing on 2 things. One is block cipher and second one is stream ciphers. Algorithm that ends a fixed size of n bits of data known as a block at one time. There are different ways of sending the info. used today are actually block ciphers. So in symmetric ciphers, we have got a different technique called DES, triple DES, AES, IDEA, and blowfish encryption algorithms that we are going to discuss in later point of time. In block cipher, features are: one is block size. In general, larger block sizes mean greater security. We try to arrive at as much as possible large block size. Key size, larger key size means greater security. Number of rounds, multiple rounds offer increasing security. The encryption modes define how messages larger than the block size are encrypted. Very important for the security of the encrypted message. So in block cipher, it is good practice to have as large as possible the block size. Key size also must be as large as possible, and number of rounds also multiple rounds means all the blocks we shall not send in a single shot. Instead of that, few blocks first time, then few more blocks second, few more blocks third one. Because if the hacker is who is sitting in between, if he picks up some blocks, since we are sending only few, the remaining may not be available to him. Like that, when we are sending the blocks over multiple rounds to complete the entire message, then it provides better security. And also, defining how message is larger than the encrypted, that also we have to specify how we are going to split if any message is bigger than the block size. So that also we have to define. Like that, we have to provide description for each of these things. So like this it is happening. We take plain text, then using the key convert the plain text into block cipher encryption, means plain text will be larger. Then the plain text has been split into small blocks using block cipher encryption. Then block 1 we send, block 2, block 3, or we may be sending block 1 to first. After that, block 2, 3, 4 we may be sending. So like that, over many rounds we may be sending, and each of these blocks are being received at the receiver end and put it back, and we obtain the ciphertext corresponding to that. Now we shall proceed towards the next one, that is the stream cipher. So in stream cipher, a stream cipher is an encryption algorithm that encrypt one bit or byte of plain text at a time. We are not splitting the entire message as many blocks. Here, consider a message, the first bit we consider or byte we consider in the plain text. We encrypt it and send it. Then second bit or byte we take it, encrypt it and send it. Third one bit or byte we take it, then encrypt and send it. Like that. In stream cipher, we are sending the message as a stream of one bit or byte at a time. So it uses an infinite stream of pseudo-random bits as the key. Since one bit or byte we are sending, in case of block, what happens is we wanted to create the block as large as possible with maximum number of bits or bytes. Then the message used to become a group of finite number of blocks, and we used to send one block or two blocks at a time, like that. But in case of a stream cipher, we pick one bit or byte of a plain text, convert it and send it, then a second, then we convert it and send it, like that. It results in an infinite stream of pseudo-random bits as the key. For a stream cipher implementation to remain secure, its pseudo-random generator should be unpredictable, and we should go on changing the key very frequently. Because if the person is holding the key, then what happens is the entire message, which is coming in the form of stream, becomes intelligible for him. He can easily convert the ciphertext into the plain text and make the meaning out of it. Stream ciphers are designed to approximate an idealized cipher known as the one-time pad. Only one time, continuous stream we are sending it. The one-time pad, which is supposed to employ a purely random key, can potentially achieve perfect secrecy. That is supposed to be fully immune to brute force attacks. The problem with the one-time keypad is that in order to create such a cipher, its key should be as long or even longer than the plain text itself. In other words, if you have 500 megabyte video file that you would like to encrypt, you should need a key that is at least 4 gigabits long. So, in the stream cipher, since we are sending the message as a continuous stream of bits and bytes, and if the cryptanalyst or hacker catches hold of that one stream, then continuously go on picking the coming up streams and makes the meaning. So how we can ensure that he should not get the meaning out of it? The only option remaining to it, since we cannot give at the ciphertext level, only option left to us is to give at the key level. So we want to make a key as complex and long as possible. So like this, small random key, then using the stream cipher, we go on sending key stream, pseudo random string. So plain text, then it is being converted and it becomes ciphertext. It has been moved. The other side, we are applying the reverse of the encryption, that is decryption, and we obtain the plain text. So what are the differences between stream cipher and block cipher? Stream cipher operates on a smaller units of plain text, whereas block cipher operates on larger block of data. So means when we are sending a huge amount of data, we have to prefer the block cipher. Stream cipher is faster than block cipher. Block ciphers are slower than the stream ciphers. So if we want to have any live information and other things like a share market or any TV show or live show, then most of the time streaming is being used, not the block cipher things. Stream cipher processes the input element continuously, producing output one element at a time. Block cipher processes the input one block of element at a time, producing an output block for each input block. Stream cipher requires less code, whereas block cipher requires more code. In stream cipher, only one time key is used. In block cipher, requires reuse of keys possible. So application is secure connection on the web, SSL, that is using stream cipher. Then data encryption standard, application database and file encryption, we use block cipher. Stream cipher is more suitable for hardware implementation. Block cipher is easier to implement in software as well as communication channels. Now we shall look at other cipher properties, confusion and diffusion. Claude Shannon in 1949 proposed this idea of a cipher. Confusion property of a cipher concerned with the ciphertext and the key whereby it provides no clue between the relationship between the ciphertext and the key. Means total, what is the relationship between ciphertext and key is totally no clues are given. So what we do in symmetric type of cryptography, the key should be commonly known to receiver and sender, like sender and receiver, like that we say. So when we receive the ciphertext, we want to decrypt it. For that purpose, knowledge about key becomes very important. Here, no clue has been given, which is actually giving the relationship between ciphertext and the key. Because of that, it becomes very difficult for us to recover the original plain text after decryption. This will frustrate the cryptanalyst who uses ciphertext to find the key. If a single bit in keys is changed, most or all bits in ciphertext will be changed. For example, I mean, if we are sending, assume that the 8 bits 0101010101, we want to send it. If one bit is being changed there, the entire meaning of the message itself is getting distorted. Diffusion. This is the property of a cipher concerned with the plain text and the ciphertext. In confusion, it is a key and ciphertext. Here, plain text and ciphertext. We hide this relationship here. Diffusion implies that each symbol, character or bit in the ciphertext is dependent on some or all symbols in the plain text. If a single symbol in the plain text is changed, several or all symbols in the ciphertext will also be changed. Since one-to-one mapping is there, then there should not be any changes. Diffusion holds if the statistics of a block of the plain text is irretrievably dissipated or scattered across the block of its ciphertext. Changing a single bit in block of the plain text will have the effect of changing each bit of the block of ciphertext with 50%, 0.5 probability, because the 0 and 1, these combinations only we are using whenever we want to send the message in the form. So 1 is distorted means 50% of this one probability of distortion is happening there. This will frustrate the cryptanalyst who uses the cryptanalyst statistics to find the plain text. So these are all the things we wanted to communicate. In brief, now we are all set to enter into the things functionally, how it is getting implemented. In today's session, we discuss about transposition ciphers, and we discuss about block cipher and stream cipher and property of confusion and diffusion. In transposition ciphers, rules becomes very, using the rules, we are changing the position of the text and we will be sending it. And block cipher and stream ciphers, block ciphers becomes very crucial in the sending the information related to database and things, and they are related to software implementation, whereas Stream ciphers are related SSL and other things. They are actually related to hardware implementation of computational resources. Then we discuss about property of confusion and diffusion. In confusion, if we are actually hiding the relationship or connectivity between ciphertext and key, what type of confusion it results in, that we have checked. And diffusion is another technique where the relationship between plain text and the ciphertext is hidden. So these are all the things we discussed today, and in next sessions, whatever we discussed in the form of the different ciphering techniques, those will be of great help in functionally implementing the cryptography, so that the sender, when he wants to send the plain text, by making use of encryption algorithm and key, he converts into another form, that is the algorithm converts into the ciphertext form. Then it is being sent over communication channels. Then sender, after receiving the ciphertext, he is applying a decryption algorithm along with the inverse of the key to retain the original plain text. So like this, the plain text, ciphertext, and key, encryption algorithm, decryption algorithm, these are the 5 important key terms that are going to play very crucial role in cryptography. With this, we came to the end of this session. Thank you.